As of now, the highest share of the data economy's value is generated in the finance sector. The second largest share is represented by the manufacturing industry. Data spaces for manufacturing represent a specific evolution of the general concept of data spaces, adapted to the needs and peculiarities of the manufacturing sector, where manufacturers, suppliers, distributors, clients, service providers, and other stakeholders can share, integrate and use data collaboratively and securely as a powerful alternative to non-interconnected ICT systems which communicate bilaterally. Data spaces can have important impacts on manufacturing companies' value chains, such as increasing operational efficiency, e.g. production optimization, predictive maintenance, reduction of consumption and of costs, flexibility and adaptability of products and processes, monitoring and management of the supply chain, new product development, transparency in commercial relationships, risks mitigations and resilience, regulatory compliance. Manufacturing data spaces also facilitate improved decision-making and innovation processes and facilitate the creation of new business models. Technologies like IoT, digital twins, AI machine learning ensure the exploitation of secure and scalable data sharing. Data ecosystems and data spaces should become an integral part of the company digital transformation strategy. But leverage data networks in an industry value chain asks for a governance to orchestrate participants' management, compliance to data privacy, and security regulations, data exchange services, data exchange operations of data coming from distributed platforms and management systems. For this reason, some standards and frameworks for the construction of data spaces have been established. A possible representation of a data space structure can be seen in this picture, where we distinguish technical building blocks that enable the implementation of the technical architecture through the integration of the different systems and platforms used by the participants to the data space. Technical building blocks must assure data interoperability for efficient data exchange among participants. Data interoperability is achieved through data models and formats that facilitates a common format for specification and representation of data, data exchange API that facilitate data sharing and exchange between data space participants, data provenance and traceability to enable traceability of provenance, access, and usage of data, data sovereignty and trust to guarantee that participants in a data space can trust each other and exercise sovereignty over the data they share based on user-controlled consent. It is achieved through identity management that provides authentication and authorization of participants' access and usage control and policies, ensuring trustworthiness of data sharing and exchange. Trusted exchange, reassuring participants the fairness and compliance of a data exchange transaction. Data value creation, to generate value from sharing data and create data value chains. Data value creation, to generate value from sharing data and create data value chains. Data value creation is achieved through metadata and discovery protocol, publishing and discovery mechanisms, enabling participants to find each other and the corresponding data. Data usage accounting, basis for accounting access to and/or usage of data by different users. Publication and marketplace services, directory of the data assets, management of smart contracts. Additional technical building blocks may optionally be considered to facilitate connection of additional systems to data space, systems adaptation, data processing, data routing and pre-processing, data analytics engine, data visualization. The governance building blocks contain business, operational, and organizational agreements between the data space participants. Business agreements comprise service-level agreements, data usage and access control policies, as well as accounting and pricing schemes. Operational agreements regulate policies that need to be enforced during data space operations. Organizational agreements comprise terms and conditions regarding governance bodies and procedures established for a data space. Finally, it is important to mention the importance of industry agreements. Industry actors can be reluctant or discouraged from entering the data economy. According to a study, only 1/3 of companies say they are willing to share data with other companies due to the lack of infrastructures, of guarantees about trust, data protection and data sovereignty, of knowledge of technical feasible solutions. Industry agreements are agreements on functions and interfaces between industry players that create markets and market opportunities leading to ecosystems and standards. Thus, industry agreements are mechanisms for reaching a common understanding of functionalities or architectures and specifications. They may include a variety of tools, such as, for example, federated digital infrastructures, common vocabulary standards, and also relational contractual agreements. In this concern, industry agreements have a key role in the development of streamlined and integrated data spaces, as they are designed to establish a common understanding of functionalities, architectures, and specifications.